Hi guys. So last time what we did was we had a function. We actually had the equation, and we were able to take the first and second derivative to help us graph and sketch that graph. So what we're going to do this time is we're going to be given a graph. We have no idea what the equation looks like. But what we're going to be doing is either sketching the original function, the first derivative, or the second derivative. So this takes a while. Even though there's only a couple examples, this does take a moment of thought. Okay, so take your time, come back to it if you need it. All right, so example 1 here. We have the function. We're gonna graph the derivative. Well, remember, derivatives graph the slopes. So if we were to look back, there are a couple things we know are obvious. Right here is the slope of 0, right? Because it's a max. Right here is the slope of 0, because it's max. So right away on my graph, I know at -2, I'm at 0, and at 2, I'm at 0. Now, here's where we have to do some estimating. If we look right here, what do we have? If I drew a tangent line there, what would that slope be? Hopefully, you're telling me that slope is -1. So I know that at 0, that slope is -1. Now, if we look at here at this point close to -4, we look at that slope. What does that slope look like? It looks like 2 up 2 over 1. So right here, close to -4, is a slope of 2. Let's look at this one. If we look at this point here, again, we see that the slope looks like 2. So it's a little bit closer to 3 this time. And it's at 2. And we just sketched the derivative of this function. Okay. That's the easy part. So let's look down here. What if we are given, in number 2, we're given the derivative, the first derivative, and it wants us to find the original graph. So here are some things we need to remember. When we make a derivative number line by using the location or position of points on the f prime graph, this does not involve the slopes. Okay, these are the slopes of the original function. Okay, so what we're going to do is make our number line here. And remember, when we do the derivative, to make our sign right here, we want to know where the slope equals 0. Well, the slope equals 0. This is the graph of the slopes, right? But this is the slope of f of x. So where it's 0 is approximately 3.5, -3.5. At 0, and at, let's say, approximately 3, let's do 3.5 again. Okay? Now, let's keep in mind that we don't have to worry about beyond here because the graph is stopped. But remember, this is where it's positive and negative. So between -3.5 and 0, our graph is positive, which means it's increasing on the regular graph, on the function. Now, between 0 and 3.5, we have it's negative. So on our original graph, we're going to go increasing, decreasing, which of course tells us there is a max at 0. And if we look, we have a starting point at 0, 1. So let's remember that when we graph this, there's going to be nothing up here. All right, next, we're going to make a number line with the second derivative, f double prime. Now, let's keep in mind that f double prime, we want the slopes of f prime. Okay, slopes of f prime. So if we look at 2, at -2, we have 0, because remember we want the slope of 0 or undefined, and we have another 0 slope at 2. Okay, that's all we care about. We don't care about the other slopes. We only care about where f double prime equals 0 or undefined, and that's when the slope is 0. All right, now when we're talking about the slopes of f prime, that means we're talking about increasing, decreasing. So between this -3.5, because don't forget we have a endpoint right there. Between -3.5 and -2, it is increasing. So that means these values are positive. Where between -2 and 2, it's decreasing. So it's negative. And then after 2 to 3.5, it is increasing. Now, what does f double prime tell us about our original graph? It tells us about concavity. Okay. Now, the only actual point that we can put on there that we know exists is this 0, 1. And we know it's a max right there. I also know between -2 and 2, we are concave down, right? F double prime means concave down. So I'm going to concave down. And then I know wherever I decide, okay, you can decide high or low. Wherever I decide where it hits at -2 and 2, that is going to be an inflection point, because after it concave ups. Using weird language, I guess. And remember, I'm only going to 3.5 because there's endpoints there. Now again, if you wanted, because this is a sketch, you could have totally done this and made it out more and then curved there. And this would have been a correct graph also, okay? We don't know the y values. All we know is that this point exists, and we know concavity and increasing, decreasing. I want to even show you the increase, decreasing. Increasing to 0, decreasing after 0. And that's what it shows us. All right, let's try another one. Right here, we have f prime. And we're going to go backwards to f, just like we did here. But then we're also going to graph f double prime. Okay, so remember right here, we're going to find where this equals 0. That gives us our number line, our sign ray for f prime. It equals 0 at -2. Now at -2, to the left side of it, it's below the graph, so it's negative. And on the right side of the graph, it's positive. This means that it's going to decrease to -2 and then increase after, which also means at -2, it is a minimum. I also know that the slope. Now, this is going to be, I could put it anywhere here. Okay, I don't have to put it there. But I am, just for now. I don't need to. It could be anywhere on here, because it doesn't tell me what point this actually goes to. Okay, it could be shifted up or down. Now, if I look at f double prime, I have to look at the slopes. So where it changes slope, right, is at 0. That's where slopes change. or in other words, there is our zero slope. Okay, so at 0. And it is increasing before 0 and increasing after 0. So it's concave up the whole time. The original graph is going to be concave up the whole time, which means it's a parabola. Okay, and like I said before, you could have made this the -2. It could look like this, so it can be shifted anywhere as long as it's a parabola where that minimum is on -2. Okay, that is why we're sketching. Now let's talk about f double prime. If you remember, this is the slopes of f prime. So the slope from -infinity to 0, that slope is the slope of 1. Okay. Now, if we look, there is a change in slope here. There is a sharp turn here. So that means that is a hole. Actually, because that's a sharp turn. Sorry, guys. Because that slope is 0, we have a hole right here. Those two . The other thing I want to say to you is, yes, I said the slope was 0, but since the two slopes are different at that point, it is a sharp turn. I keep confusing myself with what I'm looking at. I'm sorry. So that's why we have a jump here. Now, here, we could look at each of these separately. So we could have a curve here, or we can have linear. I'm just going to draw it linear right now because we're sketching it. But it could be curved. Most of the time, guys, we are going to be given the f prime or f double prime, and we have to find the original. That's what will happen most of the time. You need to get used to what each graph shows us of the one before or the original one. So as you can see, when I was dealing with f double prime, I was looking at the slopes of f prime, looking at it as an increasing, decreasing, because f double prime is the first derivative of f prime. No, that's kind of tongue twisting. But when it comes to the original, it talks about concavity. Concavity of it being up. Try this out. It will take time. Ask questions.